All right, today we are talking about arithmetic sequences, which most of this is a review from what we did at the very beginning of the year. So we introduced some of the terms in Unit 1, and now we're just kind of re-looking back at it and then also connecting it to function notation. So we should already know how to identify arithmetic sequences. We should already know how to identify the common difference. We should know already how to find a formula and to find a specified term. So really the only thing that's new is connecting all of this to functions and graphs. So we are going to go back and review the first four goals here. So way back in our very first lesson, we learned about sequences, and we had some vocabulary here that's really important. So a sequence is simply an ordered list of numbers. So you've got numbers that are separated by commas, and then you've got the ellipses, which is the dot, 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 often at the end. The numbers in a sequence are called terms. So this, A sub 1, sub for subscript. So A with a subscript of 1 means the first term. A sub 2 means the second term, so on and so forth. So A sub 100 would mean the 100th term. The common difference is the difference between two terms in a row. So for instance, you take the second term minus the first. It does work for any two terms that are right in a row. So it doesn't have to be second minus first. It could be sixth term minus fifth term. It is a common difference, which means it stays constant. So it shouldn't matter which terms you pick as long as they're in a row. And it does need to be the later term minus the earlier term. An arithmetic sequence is simply what we call a sequence that does have a common difference. So in example 1, determine if the sequence is arithmetic. If so, find the common difference and the indicated term. So in order to determine if it's arithmetic, we just need to decide, does it have a common difference or not? So I'm going to do second term minus first term. So 5 minus 1 gives me 4. And now I just need to decide if that's constant. So now I take the next two, and it's always later minus earlier. So 9 minus 5 gives me 4. 13 minus 9, also 4. 17 minus 13, also 4. So this common difference is indeed common. It stays constant. So this is yes. Yes, it's arithmetic. So we can say common difference is 4. And then this wants me to find the indicated term. So in this case, A sub 8. So this is 1, 2, 3, 4, 5. So A sub 6 would go up by 4. So that'd be 21. A sub 7 would be 4 more after that, which would be 25. And then what I'm actually looking for would be 4 more after that, which would be all the way up to 29. So all I did was simply continue the pattern there to find the indicated term that I wanted. All right, so looking here, I want you to go ahead and determine if the sequence is arithmetic by looking for a common difference. So go ahead, do the same thing that I did for the previous example, and I want you to say whether or not this is arithmetic, and if it is, I want you to find and list the common difference. All right, let's check your work for that part. So I have -8 minus 3, which would give me -11. Next, I have negative 19 minus negative 8. Now, if you need to write that out or use your calculator, go ahead, but remember that minus negatives become pluses. So negative 19 minus negative 8 is the same as negative 19 plus 8, which is negative 11. So now I do the same thing here. Negative 30 minus negative 19 is plus 19, which does give me negative 11. So this one is also a yes. And our common difference is negative 11. So hopefully you got that part right. So even if you didn't, now go ahead and see if you can find what the sixth term should be. So a sub 6 here if I'm continuing the pattern. All right, so if I'm continuing the pattern, that means I'm going to go 11 more down, so subtract 11. Negative 30 minus 11 is negative 41. And that would be the fifth term. And so then subtract 11 again, and that would give me negative 52 for my a sub 6. All right, now let's look at C. So 4 minus 2 is 2. 7 minus 4 is 3. 11 minus 7 is 4. 16 minus 11 is 5. So I do not have a common difference. Doesn't mean that there's not a pattern, but it is not arithmetic. So you could find the seventh term if you wanted. We're adding one more each time. 1, 2, 3, 4, 5, 6, 7. I'd only need to do 2 more, add 6 and add 7. I could most definitely find a sub 7, but that doesn't make it arithmetic. It's only arithmetic if it has a common difference, and this one does not. So not arithmetic there. So really what we've done in example 1 is just find the next term or whatever term is asked for. But if I had asked you to find the 500th term, that would take forever to continue the pattern that way. So the method in example 1 would not be effective if we were just continuing the pattern. This is where those formulas that we taught you to write in the first couple lessons are really, really helpful. This is where math becomes really, really exciting because it saves us a lot of time. So an explicit formula is an equation that can give you a term of the sequence based on its term number. And this is the same exact formula that we went through and learned in the first couple lessons. So a sub n, that means any term of the sequence, is going to be equal to a sub 1, which is the first term, plus n minus 1 times d, where d is the common difference. So I wrote it out in words too here. Nth term equals first term plus d times n minus 1. So we can check our work from example 1a using the formula. So I look and I say, okay, if this is true, then I should be able to confirm it here by saying nth term, which my 8th term was 29, equals my first term, which is 1, plus the common difference, which was 4, times n minus 1. So n, because the nth term, so the 8th term, that means that n would be 8 here. So when I simplify this, I have 29 over here, 1 plus 4 times 7, because order of operations starts with parentheses. Next should be this multiplication, 4 times 7, which is 28. and 1 plus 28 is indeed 29. So it shows that yes, I can find that term using the explicit formula. Now, most of the time, we're not going to use the formula to check our work. We're going to use the formula to find the answer. So very similarly to what we did in the first few lessons, we're going to use this formula in order to write an equation first, and then we're going to use it to find the indicated term. So first thing I'm going to do is write the explicit formula. So a sub n equals, the first term of my sequence here is -2. So first term plus, now because this is the general formula, I'm going to keep n instead of plugging in a number right now. N minus 1 times the common difference. So the common difference I need to find here. So -6 minus -2. So that's -6 plus 2, which is -4. I confirm it with the next one. -10 minus -6 is also -4. It does appear to be going down by 4 each time. So we'll confirm that. So I use this formula here, first term plus n minus 1 times d. And now I'm going to simplify that. So when I simplify that, first I need to do the multiplication. So -4 times both terms here. So -4 times n is -4n. -4 times -1 is +4. And then when I combine my like terms, which are here, I have a sub n equals -4n, and then -2 plus 4 is +2. So this would be an explicit formula. Now sometimes it'll just ask you to write it like this, and you could leave it -2 plus n minus 1 times -4. So you'll just have to pay attention to what format everything else appears to be in. Now it says use it to find the indicated term. So I want to find a sub 21. And a sub 21 means the 21st term, which means that n needs to be 21. So I'm going to plug in 21 in place of my n, and I'm going to simplify. So -4 times 21 gives me -84, and then plus 2 gives me -82. So I have two answers in this problem, the first one being the explicit formula, the second one being the answer to what is the 21st term, which is -82. Okay, I want you to follow what I did here, and I want you to go ahead and write the formula, the explicit formula, the a sub n, for what we have in example B. All right, so first thing that we should do here is find my common difference. So, looks like I have made a mistake here. So let's try this again when I actually have the right term in here. Sorry, this should be a 33. So I apologize if you were confused there. So let's try that again. Go ahead and now, using the correct information that I have here, now go ahead and find your explicit formula for a sub n. Start by finding the common difference. Write out using this formula right here. All right, so 33 minus 13 gives me 20. 53 minus 33, also 20. 73 minus 53, also 20. So that gives us our common difference as 20. When I go to write my formula then, a sub n equals first term, which is 13, plus my common difference times n minus 1. So multiply the common difference through. So that gives me 20n minus 20 when I distribute. And then I've got like terms here. And so a sub n equals 20n minus 7. So hopefully this is what you came up with for your answer there. Now we're going to go ahead and find the 37th term. So that means we need to plug in 37 for n. So a sub 37 equals 20 times 37 minus 7. So certainly you can use your calculator here. 37 times 10 would be 370. And then if I double the 370, that gives me what? 740. And then minus the 7. So that gives me 733. And that is my a sub 37. So that's the second part of my answer there. All right. An arithmetic sequence can be graphed on a coordinate plane. In the ordered pairs, the term numbers, 1, 2, 3, so on and so forth, are the x values, and the terms of the sequence are the y values. So we're going to use that to graph the sequence from example 2, part A. So I've got -2, -6, -10. Those are my y's. Remember that the x's that go with them are the term numbers. So 1, 2, 3, 4, so on and so forth. So the first point I need to plot is 1, -2. So 1, -2 goes right here. Then 2, -6. 3, -10. 4, -14. And 5, -18. So when I look at this graph, would you call this graph discrete or continuous? Go ahead and answer that one. Right, hopefully you answered discrete. Remember that continuous is when you can trace it with your pencil or finger without picking that pencil or finger up. Here, I would have to jump every time because they're just individual dots. There's nothing in between here. There is no a sub 1.5 or a sub 1.25. So you do need this to be just dots. If you connected these points here with a line, you need to go back and undo that line because we shouldn't have it there. So now we're going to choose any two ordered pairs from our graph. It does not matter which ones you use. So I'm just going to go ahead and choose the first two. So I've got 1, -2. And then I've got 2, -6. The next thing that we want to do is to calculate the slope using our y minus y over x minus x. So I'm going to start with my second point here, y on top, x on the bottom, and then bring in my second point, minus -2 becomes +2. And then I have -1 for the x's. So -6 plus 2 is -4. 2 minus 1 is 1. and negative 4 over 1 is negative 4. So how does this negative 4 relate back to my sequence? When I look at this sequence, what was the negative 4 in the sequence? Hopefully you decided that the slope was the common difference. This is always true with an arithmetic sequence. Even though we're not connecting the dots to make a line, they have a linear pattern, and the slope of that linear pattern is always going to be the common difference. So, how could we use the graph to get the explicit formula for the sequence? So, basically what we could do is we could pick out one of our terms, the top one, to find the first term, which would be the y coordinate. So use y coord of top term, or point with the x coordinate of 1 as a sub 1. That's our first term. And we could count slope using rise over run to find the common difference. So that means that we could work from a graph instead of from the sequence, because I could say, well, I know that my first term has to have that x coordinate of 1. So that means here's my dot that has an x coordinate of 1. That means my first term is negative 2. So I would do negative 2 plus, and then I would do n minus 1 times d I could get from counting my rise and run. Now be careful here because we're counting by 2's, but the rise and the run here, rise is negative 4, run is 1, which again gives me this guy. Notice that this now looks exactly like what I did up here. So we could work from the graph as well. All right, example 4. The 11th term of an arithmetic sequence is 59, and the 14th term is 74. Find the explicit formula. My strong suggestion when you are given two terms of the sequence is to draw out a picture like this with these little hops for the missing terms that you don't know in between. So a sub 11 we're told is 59. I don't know a sub 12. I don't know a sub 13, but I do know that a sub 14 is 74. So first we need to find the common difference. When I do that, I look to see, okay, from my 59 to my 74 is 1, 2, 3 common differences. So that means 3 common differences is equal to whatever the distance between 59 and 74 is. So I can say 3D equals 74 minus 59. So 3D then equals 74 minus 59 would be 15. And so then that tells me when I divide both sides by 3 that D equals 5. My common difference would be 5. So I can use this then to find my first term, because that means that I can continue to either work backward or manipulate using a picture, however you want to do it. But if I am at 59 and I am working backward, that means that if this is the 11th term, 10th term, 9th term, 8, 7, 6, 5, 4, 3, 2, and finally my first term, I'm just going to get by counting down by fives. So subtract 5 here, and that gives me 54 for the 10th term. Subtract 5 again, that gives me 49. Then subtract 5 again, 44. Then 39. Then 34. Then 29. Then 24. Then 19. Then 14. And then subtract 5 again for the final time gets me down to 9. So the first term would be 9. Now I can plug that gathered information into my explicit formula generator. So first term, 9, plus n minus 1 times the common difference. So distribute the 5. Gives me 5n minus 5. And then, like terms here, my explicit formula is 5n plus 4. You can always then check your work. I know that the 11th term was supposed to be 59. So if I plug in 11 for n, I should get 59. So 5 times 11 is 55, plus 4 is 59. So I am now very confident that I have done that correctly. All right, last concept that we're going to talk about is an arithmetic sequence when written as a function. So in function notation, the terms of the sequence are the functional values. So f1, f of 2, f of 3, f of n. So in this case, saying f of 1 is also the same as saying a sub 1, meaning that f of 1 is whatever the first term is, just like a sub 1 stands for the first term. So that's the first thing that I want you to do. So if f of 1 means the first term, write out what f of 1 is. Right, hopefully you answered -7. F of 1 is the first term. Now, f of 3, that should mean the third term. So first term, second term, third term should be -2. Now we're going to write a function f of n to describe the sequence and use the function to find f of 14. So we do this the exact same way that we have in all of these examples. It's just that now we're writing it with f of n instead of a sub n. So we're still going to use the same idea. It's still going to be first term, so -7, plus common difference, so that I need to find. So -4.5 minus -7, which means plus 7. So that should give me 2.5, I believe. And then we'll check it by doing the next one. -2 plus 4.5 is also 2.5. So we've confirmed it. So 2.5, and it's okay to use a decimal because there are decimals in the original problem, times n minus 1. This would be my function. Again, sometimes you'll be allowed to leave it just like that. Here we're going to go ahead and practice our distributing. So 2.5n, 2.5 times -1 is -2.5. And so then these like terms right here, I have 2.5n, and the -7 minus 2.5 would be minus 9.5. So this would be my function. Now, use the function to find f of 14. This is just plain old function notation that we've been doing for quite a while. That means plug 14 in. So go ahead, as your last task here, go ahead and find f of 14. Okay, so going to check our work. F of 14 is just function notation telling us to plug 14 in for our variable. So 2.5 times 14 minus 9.5. So I'm sure we'll want a calculator for that. So 2.5 times 14 is 35. And then 35 minus 9.5 gives me 25.5 for my final answer for f of 14. All right, I think that wraps us up. Make sure you reach out if you have questions.